Well, hello again, everyone watching and listening. Thank you for attending this webinar from Wavefront. This is your host, Rob Markovich. I'm the Chief Marketing Officer for the company. And you can see the agenda for today. We'll first present for about 20-25 minutes on the concept of cloud metrics and then show you a brief Wavefront product demo using example incident investigation scenario. And after that, we'll conduct about a 15-minute Q&A session using your questions. At any time, you may submit a question in the box below the presentation box of your webinar window. You may need to scroll down in the window to actually see the question box. And we'll gather all the questions for the end and try to answer as many as we can. And just to let you know, we will record this webinar and make it available to you for future viewing. I will now pass the baton to our presentation speaker, Dev Nag, who will introduce himself and go from there. Dev, let me switch over the controls to you. It might take a couple of seconds.
Welcome to the Wavefront Introduction webinar. I'm Dev Nag, founder and CTO of Wavefront, and I'll be showing you what we do and who we do it for. In this webinar, we'll introduce you to cloud metrics, discuss the trends that have led to a number of new problems in modern tech operations, explain how we address that problem, and talk about where the legacy technologies are starting to show some gaps. We'll then go through a product demo where you'll get a chance to see why the biggest SaaS companies in the world, companies like Microsoft, Workday, Box, Intuit, and many others have chosen Wavefront. And finally, we'll finish up with a live Q&A session in case you wanted to clarify anything before reaching out to us. So what are cloud metrics? Let's start by describing the operational lifecycle, the steps your team is constantly going through to keep your cloud application healthy. Your team detects issues, diagnoses them, remediates them if necessary, validates the remediation, and then does their best to prevent a reoccurrence, often by creating better alerts and automating future remediations. Cloud metrics are a way to increase your leverage every step of the way. They let you get more data across all 5 of these phases, get the data faster, in real time, analyze the data more deeply, and augment your existing tools like logging, APM, NPM, and many others. They help fill in the gaps that these tools have a hard time addressing with modern cloud infrastructure. By giving you this much deeper and faster access to operational data, cloud metrics help you accomplish 2 of your most important goals: keeping your cloud application running and increasing your product velocity. Who needs Wavefront? Customers running revenue-generating cloud applications. If you look at the sampling of our customers on the right, you see some of the biggest SaaS names in the world, all of whom depend on Wavefront for their operational needs. They're companies who use modern cloud technologies, such as public cloud, hybrid or private cloud, microservices, containers like Docker, virtualization, and aggregation. If these are technologies that you use or are beginning to use, Wavefront is made for you. Let's talk about the trends that have led to massive and dynamic complexity in cloud architectures. First of all, we have an explosion of new technologies: containers, microservices, virtualization, aggregation, software-defined network, software-defined compute, software-defined storage. If you log into any public cloud, you'll be faced with 50 or more technologies you can use from day one with a single API call. The second big trend is a fragmentation of the stack. 15 years ago, we actually had a stack: a presentation layer, an application layer, a data layer. Request goes down, response comes back up. Those days are long gone. We don't have a stack anymore. We have a graph of microservices in the internal graph, and data stores, message queues, caches, third-party SaaS vendors, and much more in the external graph. That's far more complex than what we used to have. The third big trend is the divergence of dev and ops. What do we mean by that? We mean that the environments where you write your code and where you run your code have gotten increasingly dissimilar. You can test locally all you want, but once you push your code to production, you're going to see a bunch of potential issues that are untestable. Broken configurations, API calls changing without warning, hardware or services disappearing on the cloud. And as these 2 environments of dev and ops have diverged, the people have had to converge to compensate. This is the rise of DevOps. This is the rise of canaries. We didn't used to use canaries as heavily as we do today. Nowadays, we expect to push our code to 1% of production, then 3%, then 5% before doing a full deploy, precisely because we know how many more issues local testing does not catch. Put another way, There are far more moving parts, interacting in far more complicated ways, unpredictably and dynamically. And there are three big consequences of that. The first consequence is that every single system is a snowflake. Every single one of our customers has a custom architecture unlike any other. They use that portfolio of technologies in different ways, set up their microservices in a unique configuration, and have issues that are really specific to them. The second consequence is that components cannot be managed in isolation. Let's take a simple, almost trivial example. Suppose your CPU load doubles from the baseline. Is that a good thing or a bad thing? Well, perhaps we just had a huge marketing campaign and there were new users flooding into your SaaS application. That could be a very good thing. On the other hand, perhaps you just tried to fix a UI bug with some new code and seem to have introduced a brand new server issue that's eating up your CPU cycles. That's a bad thing. And because of the first two consequences, we see customers making a massive shift from using system or infrastructure data as the primary source of operational visibility to application data. The operational complexity has moved to the application layer, and that's where they need to look deeper. So what are the problems caused by dynamic complexity? We'll just go over the top 5 that we see. The first is alert fatigue. Too many non-actionable false alerts burning out your team. In a complex system, you can't judge good versus bad with simple linear thresholds, and that causes many, many false positives. The second problem is developers being swamped by operational responsibility. Because the complexity has moved to the application layer, developers are on the hook, operationally speaking, which ends up lowering product velocity. The third problem is that it requires far too much manual work to investigate issues across a portfolio of monitoring technologies and trying to reconcile all the different views into your data. The fourth problem is that most incidents in these complex cloud environments are unique one-offs. New incidents tend not to look like incidents that came before. The bottleneck or issue has moved elsewhere. This means that standardized runbooks have become less useful, and that each incident takes too long to detect and resolve because you're always looking for something new. And finally, these architectures have become much, much harder to QA. Developers may joke that they'll just QA a given feature on production, but that is increasingly becoming the reality. Now, if you ask customers why the legacy technologies don't quite work in this new world of cloud architectures, they give you surprisingly consistent answers. It comes down to 3 big gaps. The first gap is that these tools are not unified. Remember, in this complex graph of microservices, to understand any part of the picture, you need to see the whole picture. That means having access to all the data in one place, as opposed to having to slowly put it together across different monitoring silos. The second big gap is that these tools are not quite real-time. They may poll a system every minute or every 5 minutes, or incur extra latency during processing and extraction of log data. That's a problem for operational use, when you need to dig into your system right now, and you can't afford to wait for that data to slowly come in. The third big gap is that the analytics that these tools offer is either weak, meaning you can't ask deeper questions about the operational data, or slow, meaning that, again, they're not quite running at the same speed that you need to be operationally relevant. What if you could fix all 3 of these gaps with one product? A product that allowed for unified data with real-time analytics. Well, we have that technology, and it's called Cloud Metrics. Cloud Metrics allows you to see all of your data across your entire cloud. Here's a typical cloud architecture with conceptual layers. Everything from the basic network access and power up through compute and storage to containers, data stores, and your application code, all the way through transaction, user, and business metrics, your KPIs. All of these different layers of data can be sent into Wavefront as unified cloud metrics. Your team can then ask deep questions about that data, gaining the insight they need to detect, diagnose, validate, and prevent issues all in real time. The time between that data being generated anywhere in the world and it being available for queries is on the order of a few seconds. So how do you integrate with Wavefront? If you look at our existing customers, they tend to have very complicated environments. They may have a combination of data centers and public clouds with locations all over the world, each of which is constantly changing in terms of layers and nodes. What Wavefront does is to give you a little proxy application to run that basically just packages up all the incoming data for that data center and ships it to our cloud in a real-time stream. That proxy is the only Wavefront code you run locally, and it's all open source to make it easy for your security team to validate. Once your data is in the Wavefront cloud, your entire global user base has real-time access to it. Many of our customers have far-flung teams spread all over the world who need to collaborate in real time and at large scale. Each of the customers you see on the right here, Box, Microsoft, Workday, Intuit, and Lyft, has hundreds of active Wavefront users. This includes IT and ops, but increasingly, it includes the developers who are performing the ops function for their piece of the complex cloud application. One of Wavefront's most important qualities is our ability to scale and handle hundreds or thousands of users doing queries and looking at dashboards and running alerts all at the same time. So let's go back to the problems that were emerging with these new cloud architectures. How does Wavefront address them? For alert fatigue, Wavefront allows you to create smart alerts that go far beyond simple thresholds to track your system's complex behavior for what's normal and what's not, greatly reducing false positives. For developers who are swamped with operations, Wavefront gives your developers self-serve operational analytics so they can instrument their own code as deeply as they want, understand where the issues are, and do their job faster. To avoid too much manual work, Wavefront gives your team a single, simple, real-time interface to almost all of their operational data, so they don't need to spend time manually tying these insights together. To deal with the fact that most incidents are unique one-offs, Wavefront gives your team agility over rigidity with real-time visual analytics, so that even if they don't ask the right question the first time, it only takes them a second to see and iterate their question and dig into that particular incident. And finally, to cope with the fact that these systems are much harder to QA, Wavefront makes it much easier to compare production against staging on any part of your system, any level of the stack, and especially cross-system during canary deployments. Because metrics are such a universal format, we can instrument almost any technology you might be using, whether they're databases, caches, containers, clouds, message queues, storage, proxies. We can read metrics off of anything and everything. And of course, most importantly, you can send metrics straight from your proprietary application code. Finally, I want to briefly describe our architecture, which is a big part of why companies like Box and Workday and Intuit chose us. Many of our customers tried to run open source metrics platforms before they came to Wavefront, but found massive issues with scale, power, and reliability. It's a truism that your monitoring system has to be more reliable than whatever system it's monitoring. For us, that means 4 nines uptime, because SaaS companies cannot afford to be flying blind and missing production issues. Every Wavefront customer sits on a highly available cluster with full disaster recovery spread across multiple availability zones. Each subcluster above, both the pink and the green, is capable of taking the full data ingestion rate as well as the full query load of all the users on that system. For our larger customers, we also offer the option of a private or a single tenant cluster for full data and process isolation shared with no one else. We also offer highly elastic capacity. Whether you're sending 5,000 points per second or 1,000,000 points per second to Wavefront, we can adapt our capacity to your needs with zero downtime. We also perform all version upgrades of the Wavefront application with zero downtime, no hiccups in data processing, queries, or alerts. That's what enterprise grade means to us. And now, I'm pleased to show you the Wavefront platform in action. Let's talk about your operational or development team and the process they're constantly going through. Detect a problem, diagnose it, remediate the problem, validate the remediation, and finally, prevent it for next time. We're going to go through an example problem from beginning to end, and I'll go at a slow pace so you can see everything. Suppose you have a KPI, or a really important metric that drives your business, like user transaction rate, and you have an alert in Wavefront go off telling you that it's dropped by 10% for more than 3 minutes. You'll get an immediate alert based on the rule you set up. Here it happens to be an email, but Wavefront alerts can also go through PagerDuty or any webhook call. You'll see the email includes the alert name, the severity of the alert, a link back to the triggering condition, as well as a link to a dashboard that promises much more context around this issue. Now, let's check out this dashboard. It offers a whole bunch of relevant context for this KPI. We see the transaction rate drop at the top left chart here, along with a bunch of other data, including single stat widgets, stack charts, point plots, table widgets, and other visualizations. Back on the KPI chart, we can zoom in or out, drag forwards or backwards, and then synchronize the whole dashboard to that time frame. By the way, we can also take this dashboard and get a short link at any time, which will preserve the full state of that dashboard with any changes you made that you can send to anyone else, store in an internal wiki, etc. Anyone who opens that link later on will get the dashboard as it was at the time you sent it, even days, months, or years later. Now, sometimes you'll see some clear context right from your dashboard. But suppose this is an especially difficult case, and suppose that we're not seeing any other obvious metrics acting up at the same time. It's not clear what caused this drop in our KPI, or where we should start looking. First, let's figure out if our transaction rate drop was tied to some particular class of demand, like user type, or some particular class of resource, like application server. Here's the raw KPI that we saw before, dropping. Let's break this down first by customer segment and then by application server, pivoting by these two different dimensions. If we first break it down by customer segment, we see that a bunch of different segments had the same rate drop at the same time, so it doesn't seem to be tied to that dimension. It's across the board here. But maybe it's not about the users, but about our hardware. Let's pivot by a different dimension and break it down by application server. And there we go. A single application server seems to have suffered some issues, but didn't get marked down and properly shift its load to the other app servers. We might go ahead and manually mark down that server right now and make sure the total transaction rate recovers, and then ask ourselves, what's going on here? What caused this problem? Let's open up the KPI chart. We want to figure out the root cause of this issue. We're going to use a Wavefront feature that kind of looks like magic. We're going to search a whole bunch of other potential metrics to find the metric that acted the same way at the same time. Let's talk about these potential metrics. The transaction rate drop on this app server could be tied to something at the infrastructure level, like CPU or network, or some bug within the application itself, or some combination. Let's load all that stuff just to look at it on one machine. There might be hundreds of these metrics, all at completely different scales, with, again, nothing obvious sticking out that looks like our KPI drop. What's the trick? We're going to use Wavefront's correlation function to find the top matches in just a few seconds. Let's look for the top two matches by correlation. We found two matches, but they're scaled much smaller than our KPI drop, so it's very hard to see the underlying structure. If we shift these two matches to use the right axis, while leaving the KPI on our left axis, we can compare the shapes directly. We can see that one metric looks very similar to the KPI drop. If we mouse over it, we can see it's the memory on that app server dropping like a rock. At the same time, we also see another metric for garbage collection that has spiked up. That seems to be the issue that's hurting the transaction rate, but not marking down the server. Garbage collections that are exacerbated by memory pressure. Suppose we figured out that it's a garbage collection related bug in our service markdown code. We have what we believe is a fix, and we want to make sure that we've deployed the code properly. Here you can see we have the version numbers as metrics, and we're deploying the new code to that app server first. We can see the minor version metric move up as expected from 107 to 108, while the remainder of the app server stay at minor version 107. Now that we've upgraded the application server, we can bring it back into live rotation immediately. Note that the transaction rate, which was very choppy during the incident for some time afterwards, recovers and stabilizes on cue. Depending on our operational process, we might upgrade the whole fleet immediately or give that one app server some extra time to burn in the new code before proceeding. Note that we're once again using the dual axis feature of Wavefront, showing the transaction rate on the left axis, but the minor version on the right axis, so it's easy to visually compare. Now, we had a couple of issues here. The free memory dropped, and we saw a rise in garbage collections at the same time. We think we fixed the markdown issue in the code, but suppose we wanted early warning on memory issues like that. We can simply create an informational non-paging alert for that. We can check to see if it falls below a threshold, like 7 gigabytes free, or we can see if the rate drops below a certain percentage, like 20% or more within 2 minutes, or anything we want. That way we can get ahead of it, just in case it has some other consequences besides the service markdown bug that we found and fixed. That's just a short course, a tasting menu, if you will, of how Wavefront is used in production at some of the largest SaaS companies in the world. Companies like Box, Microsoft, Workday, Lyft, Intuit, Okta, Citrix, and many, many others. Thanks for watching, and stay tuned for our live question and answer session.
Okay, this is Rob again. I think I've got the controls. Dev, thank you. That was a good overview of Cloud Metrics as well as a pretty concise demo of the Wavefront product, and as you said, a bit of an hors d'oeuvre of kind of its full capabilities. Let's now move over to the Q&A session, which is always fun. And I actually see a number of good questions that have already been submitted. Again, you can submit a question by typing it in the question box below the presentation box of the webinar screen, and we'll take it in and we'll try to answer as many as we can. So, Dev, in addition to taking questions, I also want to introduce another person that has stepped into our studio, and that is Connor Beverland, who is Wavefront's Director of Customer Engineering, and he's ready along with Dev to tackle the questions that are being submitted. So, guys, I'm going to start with this question. Number one is somebody has asked, how do you actually get your cloud metrics into your system? Do you have your own agent?
Yeah, Dev Nog here. So we have a combination of approaches. One approach is to actually do our one-line install for infrastructure monitoring. You can actually pull down both Collecti and the Wavefront proxy with a single command, get it all up and running in a few seconds. And obviously for more custom application metrics, you can send those directly to the Wavefront proxy. That's all open source. It's all out there. And you can also take a internal message queue like Kafka, put all the data in there, and then send it back out to Wavefront like a bunch of our bigger customers do.
Great. Just looking here, there's actually another related question on metric ingestion. The question is your architecture based on a push or pull model for taking metrics in?
So it's mostly a push model. No one really wants a SaaS provider to reach inside their firewall and have all the security credentials for doing that. So primarily customers push data to us. There's an exception around CloudWatch data. So we have a very easy way of getting all your data out of CloudWatch if you're running on AWS or if you have a portion of your infrastructure running on AWS. So for cases like that, for cloud services, we try to pull the data directly. But for data residing inside your own environment, you push it to us.
That's great, Connor. Actually, that answers yet another question someone had asked, and that was, can you take in metrics from the AWS services I use?
Yeah, so within minutes, you can get data flowing in from AWS, and we have some really nice pre-built dashboards showing you information about how much your spend is, how you could reduce that by using reserved instances and things like that. That's all things you can get really, really quickly.
Very good. Just looking here. Okay, so there was a question about the Wavefront proxy application that Dev mentioned, and the question was, how big is that piece of code, and what functions does that software actually do?
Yeah, so the proxy, and we call it a proxy, not an agent, because it doesn't collect data by itself. That's what we actually bundle Collecti with our proxy. The proxy basically handles listening for data that you push to us, as Connor mentioned. It does the authentication up to our cloud servers. You can have many of these as you want. A lot of our customers have 2 per data center in an HA fashion with a VIP in front of those. And they basically handle authentication, and you can actually do some local throttling. You can say how many points you want to be kind of maxed out at each agent if you want as well. And we allow some sort of remote management capabilities as well with the proxy agent.
Okay, very good. Just looking here, one of the more recent questions is what time series database do you use in your back end?
That's a great question. So we started the company about almost 4 years ago. We looked at everything on the market. We looked at OpenTXDB and InfluxDB. We looked at WhisperDB and the other kind of graphite options. We looked at HBase, everything kind of one level down. Nothing really fit the bill in terms of what we wanted. We came from Google and Facebook and Twitter. We had a lot of data coming in, and none of those systems could scale to even 200 or 300,000 points per second, much less a million points per second, like we knew the world would kind of move towards. So we actually built our own. We built our own time series database from scratch. That's one of the crown jewels of Wavefront, and we've had great validation of the marketplace.
Good. As I'm just scanning the questions, I'm trying to lump them together. There was another question related to time series database, and the question was, I assume that you downsample historical data in the database. What's the details on that?
So another amazing thing about Wavefront, and one thing that we did not like about the existing options, is that they all downsample data. They summarize the roll-up data. They might do it after some user-defined period of time or after some automatic period of time, but they lose the fidelity of the data. Wavefront does not do that. We actually keep our original data forever. So we have data from our earliest customers going back 3 years at the second level. We've never rolled up or summarized data at the data layer. We do it during query time dynamically whenever you actually request a chart or a dashboard.
Very good. I just see that there is a question that came up on the proxy agent again. Yeah. So the question was, is the proxy agent mandatory?
It's something that we definitely recommend customers to use. I think one other thing that it does is that it becomes a queuing point. So say there's any network issue between you being able to ingest data to our service, you obviously never want to lose that data, and the proxy will queue it up locally. And so that's really one of the main reasons why we strongly suggest it. Technically, of course, the proxy is posting data to our service, so there are ways around it, but we always recommend to use it. And it's very small and lightweight, so it's easy to run. It takes minutes to install, so it's not really a big deal.
Yeah, because the proxy is open source, it's all on our GitHub repo at Wavefront HQ. You could theoretically take what it does, the server calls, and basically compile that into a library if you wanted to. We wouldn't recommend that because of all the kind of added features that Connor mentioned, but it's possible.
Excellent, guys. This one is always going to come up. How is the pricing work for the product? You want to talk about that, Deb?
Sure. So if you Google, we actually have a pricing page. If you Google for Wavefront pricing, it will be the first link there. It's basically equivalent to $15 per host per month, assuming you send about 100 metrics, different metrics every 10 seconds, so 600 metrics every minute for each host. Obviously, if you send more metrics per host or fewer metrics per host, it'll go up or down based on that. But you can kind of, eyeball it at about $15 per host per month.
Okay, good. There's a number of questions that are kind of related to comparing to other tools. So why don't I start with this first one is, how do you compare with an APM tool, for example, like New Relic?
Yeah, so one of the biggest things about New Relic is that it really looks at one part of the application in detail, just the application layer. It doesn't look at the entire system. It can't handle, device metrics or user metrics or behavioral metrics as well as we can. We're really like a huge pane of glass across all those systems. We actually have customers who use New Relic alongside Wavefront. They take the data from New Relic and send it into Wavefront to have that kind of broad pane of glass across everything. Then they can dig into New Relic or App Dynamics for more details on the app layer if they want to, or into Splunk or SolarWinds for the NPM stuff. So you should think of Wavefront as being sort of like the broad view across the entire system, and then you can dig down into other platforms for the siloed effect.
Very good. Related along this line of questioning is, how do you compare to a log analyzer like Splunk? They're claiming to ingest time series metrics and analyzing them too.
Yeah, so we have a lot of customers who use logging alongside Wavefront as well. I'd say, most of them use Splunk or, the Elk Stack or maybe Sumo Logic. Logging and metrics are very complementary. Logging is really focused around event data when something happens. Metrics are around behavior over a long period of time. If you're doing something like security monitoring where you care about individual IP addresses from, possible hackers, or you care about user authentication, like you need logging for that kind of use case. But for the behavior of your entire system, for every component of your software application, for all the devices, and for the kind of broader, behaviors over time to look for degradation, metrics are actually a far more effective, fast, and cheaper way to look at this data. It's much more amenable to the developer lifecycle than logging is, and that's kind of like how our customers use us.
Okay, very good. Question kind of related back to the agent. So somebody asked, comparing to some other tools like Datadog that include a data collection agent in their product, it looks like you guys are leaving it to things like CollectD and Telegraph. In the future, do you plan to build an agent?
We're always open to that idea. We found, I think that our customers really have a big demand for proprietary application metrics. It's about what their stack is doing, the behavior of their microservices, and the interactions with the outside world, like, message queues and data stores and so forth. So I think for infrastructure monitoring, we're not going to find that to be a huge focus of Wavefront. We'll make it obviously easier to get on board, but we're not trying to compete with Datadog, for like the small teams of 5 or 10 developers. We have customers who have 400, 500, 600 developers all using Wavefront. That's the kind of scale customer that we kind of are used to right now, and I think we'll maintain that in the future.
I'd also add to that in many of our customers, they were already using a variety of things to collect their metric data, both for infrastructure and custom application metrics. And what we try to do is be very agnostic to where that data is coming from. Like, you've already got some data, great, send it to us. So the proxy agent that we're talking about can actually listen for data in several different data formats, including many of the common open source agent formats. So it makes it pretty easy to get data from anything. And what we found that pretty beneficial, actually, like being able to go into a customer and saying, you can get started today with all your existing collection without having to start from scratch.
Sounds good. Here's a question that I kind of interpret in kind of, you can kind of comment in two ways. One is somebody wrote, this looks like a great first responder tool. Maybe you want to comment on that, but then as well, is there any way to pivot out into other tools to then look at, more findings, for example, to pivot out into something like Splunk?
Yeah, that's a great question. It's actually in our product roadmap. So we're used in a bunch of different ways, as I mentioned during the webinar. We're used to detect and diagnose and help remediate, and then validate remediation to prevent for next time. We are used increasingly to diagnose deeper and deeper, but there is a need to go to something like Splunk in certain cases if you're tracking down a single user or a single sort of event type of information. We're actually going to offer a much deeper Splunk integration very soon. I think it's targeted for Q1 of next year right now. And that'll allow you to actually go from Wavefront, if you see an anomaly or a blip or some unusual behavior in Wavefront, be able to do a right-click deep into Splunk, get that deep search to see exactly what's happening at the log level, and be able to go back and forth, right? Have log data go into Wavefront and have Wavefront anomalies go over to the Splunk search.
Good. Okay. I see a pair of questions that are kind of semi-related about, I'm using one tool and I want to, if I migrate off of it. So one question is, I happen to be using Graphite and looking to get off of it. Do you have other customers that have done that, and any comments about that kind of migration?
Yeah, I would say more than half of our customers have come from either Graphite or OpenTFDB. We made our metric format very similar to Graphite for that reason, because it's very close as a drop-in replacement. It just works way faster and way better for a bunch of functionality. I think for Graphite, the only biggest difference we have right now is that we support point tags. So you're probably not used to point tags. You may have a lot of munged metric names where you sort of take all of the different key value pairs and put into one metric name. Wavefront is more like OpenTSD, where you have more flexibility around having, a bunch of key value annotations on the data itself.
Very good. And then a similar question is, if I move from something like Datadog to Wavefront, have you had customers who've done that? And, what would I miss or gain?
So we have had some customers that have done that, and I think what you would gain is the breadth of analytic capability that you hopefully saw in the webinar. I think there are a lot of features in the Datadog product. I'm not sure that we cover all of them, but I do remember one particular customer who, upon seeing Wavefront, told us that they saw in Wavefront everything that they were missing from Datadog, and for their use cases, they didn't see any gaps.
Okay, just trying to organize my stuff here, but thanks for all these questions so far. I'm just trying to go through them. Okay, so here's a question that came up. So, Dev, in the demo that you showed, how long does it take to configure a dashboard like that?
Yeah, so creating dashboards is a WYSIWYG process. It's very easy. We don't have you could do it through JSON if you wanted to do a programmatic approach to it and just upload the dashboard through the API. More commonly, it's simply taking a bunch of charts and sort of dragging and dropping them onto a dashboard. And so if you look around, if you have friends at Box or at Workday or Mixpanel or any of these customers, you'll see a bunch of Wavefront charts on, 100-inch monitors around their offices, and they're all created in a few minutes. It's very easy to do so. I think, once you get the data in, The dashboards are very easy to create and then very easy to consume as well. You might have a power set of users, maybe 10 or 20% of the company that knows the language really well, the query language, and then have a lot more people who sort of use that dashboard capability passively.
Very good. There's a couple questions on alerts here as we kind of get close to wrapping this up. But one question was, so can you explain how you actually create alerts in your product? How is that done?
Yeah, so every single chart on every single dashboard inside Wavefront actually has a create alert link at the bottom. You can go straight from any chart right into the alert manager, which allows you to continue back testing your alert expression and change it if you don't like how it's behaving. I didn't show this on the demo, but you actually can see how many times it would have fired for a given condition in the past. If it's too noisy or not noisy enough, if it's not catching true positives, you can change it on the fly. And then, of course, you can change how often it's being checked and how long the condition has to be true for. And finally, like what target it goes to, whether it goes to an email address or an email alias, perhaps a PagerDuty API call or a webhook call.
Very good. And then related is a question said you alluded to smart alerts. Can you kind of detail more how sophisticated your alert conditions can be?
Yeah, so one of the things that Wavefront offers that's, I think, completely missing in everything else that's seen on the marketplace is control flow. So we have an if command. You can actually look for all kinds of different conditions. You can chain together Boolean conditions. You can actually do functional composition. These are all time series functions that take in time series and push out time series. So we have, some customers that have incredibly complex alert conditions that would have been, Python scripts before and are now all inside their monitoring platform. If you think about the old style of alerts, it's basically like, some metric is bigger or less than a threshold. With Wavefront, you can do, if metric A is bigger than metric C, but metric D is less than metric E divided by metric G, you can do all these kind of combinations and express exactly what's normal for you inside your complex system, and then make sure you kind of pinpoint the true positives against everything else.
Okay, and I think you might have answered this, but I'm just going to read it out. So how are you manipulating the metric visualizations in the demo? Is there some type of query engine?
Yeah, so part of writing our own time series database was also writing our own query language and our own query engine. Again, query performance was a big problem that we saw when we looked at OpenTCP and Graphite. They weren't fast enough. And so we wrote our own from scratch, looking at common access patterns and organizing data in the right place during ingestion to handle that. So I think if you go on the website, you'll see our million points demo where you can actually load 1 million points across an entire year of data in 1 second and look for, big anomalies and spikes up. That's something that we had to build from scratch. That's not kind of something that comes for free with the time series database.
Okay, very good. Here's a good question, kind of a little different direction. Is there an API to query raw metrics? And if I want to use, say, another dashboarding tool, I don't know, Grafana or something, right?
Yeah, so everything that our front end does is just calling APIs, and those APIs are all publicly exposed. So you can do everything without our front end, should you wish to, including running queries. And even the complex queries, like Deb was just talking about, if metric A is bigger than metric B, but it's also less than C divided by D, or whatever, those can all be run and have that data come back to you in JSON, which you can then use in other systems. And I've seen examples where customers have used other UIs, like Grafana, on top of Wavefront, but I've also seen cases where customers will take data from Wavefront and Wavefront queries, combine that with other data in their environment with other systems, and then push it to other systems, or indeed push it back into Wavefront as new metrics.
Excellent. Okay, I think I'm going to take one more question here, and I think this is a good one to wrap up. How long has the product been used by customers in production?
Yeah, so we started the company in January of 2013. We were in production by November of 2013 with Workday and with Microsoft on production for core needs and replacing existing systems. So it's been about 3 years in hardcore production use with very large customers.
Great. Hey, Dev and Connor, I want to thank you for your time. I think everybody in the audience, our time is up. Thank you again for watching and listening in. Again, we will make this webinar recording available for you to look at a later time or pass to your colleagues. I think the way the system works is you'll get an email in about an hour or so with a link. And of course, you can check us out at wavefront.com. If you want to talk to us live or get deeper, you can just hit the Contact Us page and fill that out. We also offer a live demonstration of dashboards of our product, and you can also request a free trial as well. So thanks again, everybody, and look forward to speaking with you on another webinar. Goodbye for now.
Thank you.
Thank you.